Let's review extensions. So when we went over how we can create a computed property for the extension through an extension to array. And in this case, we made a very useful Boolean that tells us if an array is not empty. And if I were to run this, we can see that this array is definitely not empty. And then when we call is empty on our array, we see that, yes, indeed, it is true that this array is not empty. So this is a perfectly valid implementation of is not empty. You can totally, use this in any future project that you like, and it's going to be really, really helpful. Another way to implement is not empty is not through the concrete type. So this is a concrete type. I sometimes call it explicit type. Paul Hudson likes to call it concrete type. Let's use his words. I like his words better. Another way to implement this same functionality, but this time we're going to do it not through the concrete type, but through the protocol. And the protocol that we're going to use is collection. So same idea, right? We want to implement something similar to is not empty, but let's call it something different so we know that it's different. I'm gonna just call it not empty, right? But it's gonna do the exact same thing, is empty false, right? So same logic, right? It's going to return the exact same logic. We just called it something a little different so we can distinguish between, hey, are we talking about, the extension that you made to the concrete type? Or are we talking about the computed property that we implemented through the protocol extension? So let's run not empty on our array. So we still have our array, and then we can call, this time we're going to call not empty. Let's print out the result. And just to keep things simple and sane, I'm going to comment out that line. So we only have one print statement going to the debugger. And sure enough, it works exactly the same. So you can do this either way. I wouldn't do both, but I'm just showing you that you can implement it either way, whichever way makes sense. I feel like a lot of people do this, and honestly, my personal experience is that I've never come across a case where I needed not empty for something else besides an array. So in reviewing this subject matter, I feel like I'm going to go back to my own personal project and then implement the concrete type extension as opposed to the protocol. Because it's like, this is going to cover anything that conforms to collection. And when do I ever use this guy on anything but an array? In my own personal use, it's just arrays. I use dictionaries. I definitely use dictionaries, but I've yet to come across a case in my own personal experience where I need to ask if the dictionary is not empty. But that's not the case with the arrays. The arrays, I'm always asking, is this array empty? And I'm asking that question a lot. Yeah, and it's much, much nicer than having to write, something like, this, that sucks. I don't like that. And I definitely don't like, this either. That's this is just confusing to me. Yeah. So this is a super handy, practical, useful thing to have in your tool belt. Whether you do it through the concrete type or you do it through the protocol, it's up to you. Yeah, you really can't go wrong with either one. But yeah, I mean, if you want to just, future proof yourself and not have to think about it and like just allow all of the anything that conforms to collection, do that, then yeah, go for it. But yeah, for me personally, I might just go back and, switch out that collection and then make it an extension to array. All right, let's move on. So we talked about those two extensions. I am having trouble thinking of a practical example of something like this for you to practice on it. And in my research, I found that like what I was about to propose is not technically a protocol extension. Yeah. So with that said, I would like to give you something very, very useful, very similar to is not empty. So it's going to be practical, something that you can apply right away in your own projects if you want to. And I think it's also going to help in your Swift learning. So for beginning Swift developers, this is a super great tool to have. I mean, just go ahead and copy and paste it into your playgrounds, and it's just going to make your life easier. So what is this thing I'm talking about? Well, I prepared something. Let me copy paste some code. So let's set it up. Let's set up the scenario. Why do you want this awesome code that I'm about to give you? So let's look at this code. You ever notice that whenever you print a struct, yeah, it looks fine. So you'll get, person, in this case, person Theo. That looks great. But when you do the same thing for a class, and this class is set up almost exactly like the person is. It just has one property, a name. This is just the initializer that helps us, because with classes you have to explicitly create the initializer. And if we print Fluffy here, why do we get this garbage? Why can't we have something nicer like this? Yeah, so I'm about to share with you this very useful extension, and a little spoiler alert there, that is going to help you, print classes, or specifically instances of classes. How do we do this? So, and this knowledge was not, I don't know, this knowledge is something I had to I found kind of on the internet by accident, and it's not intuitive. It's definitely not readable. I don't know who the heck named it, but it is this guy. It is this extension, custom string convertible. This is not a type. This is a protocol. Yeah, this is a protocol, right? And I'll link to this article later, but yeah. So the trick here is that we need the class to conform to custom string convertible. So I'm going to do something a little bit different from what we did previously, where we just wrote the extension and then we either, plugged in a protocol or we plugged in a concrete type. I'm going to actually put both in there. So I'm going to put the concrete type with a colon and then the protocol. So this is valid code. Extension cat colon custom string convertible. So I'm saying here that this cat class that I wrote will conform to custom string convertible. Another way to say this, and I need to also introduce this because I just learned this today, is that you can adopt protocols. So conform or adopt, use the word that you like, because it seems the community uses both. So be familiar with that. Your type will adopt a protocol, or your protocol will. I'm sorry. Your type will adopt a protocol. Your type will conform to a protocol. Either one is correct. All right, I've got a compiler error here, and this is exactly what I want to happen. Nothing to be alarmed about. Let's read it and then we'll hit the fix button in a second. So cat does not conform to protocol custom string convertibles. So it seems Apple's Xcode likes to use the word conform, but in the documentation we just saw, they like to use adopt. Again, so be familiar with both. Add stubs for conformance. So the compiler is going to offer us a fix. If we press fix, we get a computed property very similar to what we wrote before with the is not empty. But this time, the compiler's written this for us. They've written the var description string, and then, you insert your code there with between the curly braces. So what am I going to write here? So we have to return a string. So why don't I know I need to return a string. So I'm just going to put in an empty string for now, right? And if I run this code right now and I print fluffy, oops, I can't do that, can I? Type not declared here. What did I do? Curious if I move this guy down here so that it knows about the print. Yeah, okay, that does it. So yeah, so order of execution matters here. I cannot print fluffy until if I have this extension defined down here. And it's okay to do it if you're up here, but if you're down here, it's saying, well, I know you called print too early, and you've set up a way for me to print cats here in the extension. So I have to make sure that my print statements follow the custom string convertible conformance. All right, great. So I'm not getting anything in the console, and I can kind of tell that something's happening, but I don't see anything in the debug console. That's because it is an empty string. So why don't I just put in a cat? Let's run it again. Hey, cool, look at that. So if I make another cat, let's make it, yeah, I'm terrible with names. Now let's print kitty. What's gonna happen? Okay, we need some way to distinguish between these two cats. How are we gonna do that? Well, there's a clue here in the extent. Well, there's a clue definitely here in the class, right? What properties would make sense for us to, print this cat? Kind of gave it away there, but yeah, name, yeah, and because this extension is saying that, hey, we're going to extend on cat. We have access to all of the properties and all of the methods for cat. So that means that we have access to name. Great. So that means we have access. So this name, oh, too bad this isn't full-fledged Xcode. But yeah. This name, if we just click on it once, right? Just click away, click on name once. You can see that, yeah, this is, we're talking about the same name. We're talking about the property name that belongs to cat, right? We're in the scope of a cat. So it's okay for us to refer to this name. And then once we have the name, we can interpolate it. And look at that. Now we've made our cat class printable. Yeah. What happens if we add more properties? What if the cat has an age? If I print it again, oh, excuse me, I need to finish the initializer. So this is part of the burden of adding new properties to classes, is you have to always keep updating your initializer and your calls to the initializer. So I have to, must provide an age. Let's say Fluffy is 2 and Kitty is gonna be, let's say Kitty's 1. Yeah. All right, let's print those. That's totally fine. So the age just kind of slides in, but it's not surfaced in the print statement. So we're gonna have to do something again, very similar to what we did here with the age. And I could do the let age equal self.age thing, but I want to kind of shortcut that and show you another way that you can get access to these properties. Right? Let's have it print, cat name is age and then the age number. So our age number is going to go somewhere in there. What could that be? What if it's just age? What happens if I just click on this age? Does it highlight the property? It sure does. It highlights our cat's age. So this is talking to the same property there. Now if I print it, Fluffy is 2, awesome, and Kitty is 1. Hey, it worked. So yeah, it's almost as if Apple said that if you're going to make a class, a reference type, you have to take full control over the, not just the initializer, but also the printing of these classes, right? So this is almost like driving a manual car. You've got to be in control of the clutch and the stick, right? So you can shift gears and whatnot. But with the struct, it's kind of like driving automatic. You just put it in park or drive. There's no clutch. You just brake or gas. And if I add an age to this, no big deal. I can do that, and then I need to make sure that the call to the initializer is there. I'm not going to give away my age. If I print that, that's fine. That looks totally cool. But I didn't have to, do all this mess right here, right? Where I have to keep on adding more and more properties as we add more properties to cat. Yeah. It's much, much better than, the default garbage. Like, you have no idea which one is Fluffy and which one's Kitty. I mean, you could do this, but do you really want to keep doing that, for every instance that you create of cat? That sucks. So I would much rather write this once, and then I never have to think about the properties of Fluffy and Kitty ever again. Hope that's helpful. Write me some comments. I would love to hear your feedback. Thank you for watching.